So we've looked at how to display data. We looked at frequency distributions and dot plots and relative frequency distributions and histograms, which give us an organized picture of the data. And then we looked at our summary statistics, right? Our descriptive statistics, our measures of center and our measures of spread, which tell us something about the data, about the population, but we lose some information there, right? When we have a frequency distribution, we've got all of the numbers. We have all of the information. But when we look at the mean, the median, the mode, whatever, we just have a snapshot. We're going to kind of look at a little bit of a combination of that here. We're going to take some of the summary statistics or the descriptive statistics, and we're going to make a little bit of a pictorial display out of that so we can look at a picture of the population and get some sort of sense out of that. And this is called a 5-number summary, and from that we're going to draw the box plot. Now this is nothing new. We've talked about this stuff already, just not in this context. The 5-number summary is going to be the 5 numbers that break this data up into quarters, into fourths, which are called quartiles. Well, they're called quarters. The numbers that break it up into quarters are called quartiles. 2 of them are easy. One's the min, one's the max. Okay. The smallest and the biggest. I shouldn't need to say that. I'm sure I don't. The one in the middle is the median. We've talked about that, the one that's between the upper and the lower halves of the data. And we happen to have 12 numbers here. So if we count in 1, 2, 3, 4, 5, 6, we find that since there's an even number of numbers, there is no middle number, but the median is going to be the one that is halfway between those. We average them together, we'll get 14, and that number splits our data up into an upper half and a lower half. And then we want to find the numbers that break the upper half and the lower half into equal pieces. So our lower half, we have 6 numbers. The number right here, halfway between 3 and 7, will divide this into the lowest quarter and the next quarter. And that number, of course, would be 5. Add them together, divide by 2. And here, we've got 6 numbers. Halfway between 32 and 22 would be, what, 27? We add those together, we get 54, divided by 2, we get 27. So this is the minimum, smallest number. 1/4 of the data, right, falls below 5. 5 is here. 1/4 of the data falls below. 2/4 of the data, or half, fall below 14. 3/4 fall below 27. And all of the data falls below less than or equal to 60. So that's our 5-number summary. And what that tells us is that 1/4 of the data falls in each of these ranges, between 1 and 5, between 5 and 14, between 14 and 27, between 27 and 60. From the 5-number summary, we're going to draw what's called a box plot. Very easy to draw. We're going to take a number line that is evenly spaced and indexed, right? Same distance between 0 and 10 as there is between 10 and 20, etc. We're going to put a little vertical line at 1, a little vertical line at 5, one at 14, one at 27, and one at 60. And then for the middle 3, we're going to connect the top and the bottom like a box, hence the name, box plot. And then some people call this a box and whisker plot. We're going to connect the box to the max and the min. Okay, so that's called a box or a box and whisker plot, depending on who you are. And what it tells us is 1/4 of the data is in this little range here. 1/4's there, the other quarter's there. Remember we talked about that interquartile range being the middle half of the data. This box represents the middle half of the data. So we have the normal, typical individuals in there. By the way, the reason I keep making air quotes when I say normal and typical is those are sometimes used as value judgment words in stats. We don't use them to judge what's going on here. The normal ones and the typical ones are the ones in the middle. That doesn't mean there's anything wrong with these things here and these things up here. Okay, so our normal, typical ones in here, but our less usual members of the population go down to here and all the way up to there. Common misconception here is people think that there are more members of the population here because this is a bigger piece of the graph. That's not the case. There's 1/4 here, 1/4 here, 1/4 here, and 1/4 there. The bigger pieces just mean that those people or those things are more spread out. And we can see that here, right? These numbers are between 15 and 22. That's not very spread out. These things are between 7 and 13. That's not very spread out. Between 1 and 3 is very not spread out. There's still only 3 people here, but they're very spread out over the range from 32 to 60. So a longer piece doesn't mean more members of the population. It just means they're more spread out. Now, sometimes, I'm not going to hold you accountable for this because we're not going to define what is an outlier, but a reasonable person could look at this and say, that 60 just doesn't belong. If this was a town, that person is extraordinarily rich compared to this town, or extraordinarily old, or whatever these numbers happen to represent. They're still a member of the community. We want to represent that. We want to acknowledge that, but they're not typical or normal. They're outliers. And what we would do if we wanted to do that with this box and whisker plot is say, the population really only goes up to 40, but we want to put that star there to acknowledge that this person is really an outlier. Okay. So there we go. Box, whisker, a star for outliers. We'll use our judgment every once in a while to talk about outliers. We're not going to define them and hold you accountable for those. Talk to you next time.